Hello, physical systems. I am coming to you from my home to share a lecture about free fall velocity. So let me go ahead and write that out for you. So we are looking at, get my pen to work. Can I get my pen to work, please? Free fall velocity. So what free fall velocity, what that means is, well, when something is in a free fall means that it is falling to the surface of a planet, and in this case, the Earth. And so it's falling through the air, and we're calculating what is the velocity that the object has if we know the amount of time it spends falling. So yesterday we looked at acceleration, and today you guys are learning that all objects fall to the earth at the same acceleration, no matter how heavy the object is. So that acceleration gets a special letter, g. We see that little g is equal to 9, excuse my terrible handwriting on the computer, 9.8 meters per second squared. So remember, with acceleration, these are units for acceleration, not meters per second, meters per second squared, because it's the amount of time something spends changing speed per second. So meter per second, or just meter per second squared. So how do we calculate the velocity of something that's falling? Well, we have our acceleration formula. Acceleration equals to change in velocity divided by the change in time. And so here, if I know the acceleration, I know the time, I should be able to solve for velocity. And to do that, I just multiply by time on both sides. So time cancels out. Oops. Time cancels. Oops. I'm sorry, my screen's messing up. Hopefully you guys don't see that. So time cancels out on the right side. So I'm left with, so velocity, I'm gonna write it over here. Velocity equals my acceleration times time. So I got velocity right there, acceleration times time right there. And so, but since we're working just with free fall problems today, we can replace this letter A with the letter G. So the equation you guys are going to be using for the problems today, velocity equals little g times time. So given any time, you should be able to solve for the velocity that an object is falling at. So let's look at some examples together. So a ball falls for 10 seconds before it hits the ground. What is its velocity as it hits the ground? Neglect air resistance. So we say neglect air resistance because there's such a thing called terminal velocity. In other words, the air is pushing back up on any objects that's falling down. And so as an object reaches a certain speed, it can't go any higher because it's trying to push air out of the way at the same time. So we're going to neglect air resistance for now, and just focus on if there was no air at all, what would its velocity be? So a ball falls for 10 seconds before it hits the ground. What is velocity? What is its velocity as it hits the ground? So I'm just going to write the equation. If you want to see how we got this equation, you can go back. Velocity equals little g for that gravitational acceleration times time. Okay, so we know that g is equal to 9.8 meters per second squared. And we know that our time is given to us right here is 10 seconds. So all we need to do is plug everything in now. So what do we have? We have velocity equals 9.8 times 10. So our velocity equals 9.8 times 10, that's 98. 98, and remember this is velocity, so this would be meters per second. So it's 98 meters per second. So that's about the length of a football field per second. So that's how fast the ball will be going. After falling for 10 seconds, it across the length of a football field in about a second. Okay. Let's look at one more example together. So here we go. We got a good old Nicolas Cage. And he is falling for 23 seconds before he hits the ground. What is his velocity as he hits the ground? I don't think it's going to be good for Nicolas Cage. Let's find out. So we have, oh, that's an ugly color, excuse me. So here's our equation, velocity. Oh, I'm learning new things about my art tools here. Velocity, try this again. There we go, equals our gravitational constant for Earth times time. So we know, excuse me. You know that velocity, or sorry, oh my goodness, I keep on making the same mistakes. Oh my goodness. Ooh. Who says virtual learning isn't fun? Velocity equals g times t, gravity times time. And so we know that little g again is 9.8 meters per second squared. I know I said that twice already. I just want to emphasize that for you, that is something you're just going to have to remember or write down. Time is given to us as 23 seconds. So time is 23 seconds. So let's solve for the velocity. So velocity equals 9.8 times 23 seconds. And excuse me while I pull out my handy dandy. All right, so got my calculator and I found out that velocity is going to be equal to about 225 meters per second. So 225 meters is the length of about 2.5 football fields. And so if he's crossing that distance every second, by the time he's falling for 23 seconds, probably not going to end up very good for our actor here. Just one thing to remember is that this constant is not given to you in these problems. That's something you have to write down. That's true for every object. Remember, every object falls to the ground at the same rate of acceleration, and that rate of acceleration is 9.8 meters per second squared, no matter how heavy the object is, as long as it's falling on the earth, and you can neglect air resistance. So for something like a feather or a piece of paper, this might not work, but for all other objects, it should work. So those are 2 example problems. Go ahead and work on the problems below. If you have any questions, ask your instructor, and hope they're as smart as me. Guys, I will see you tomorrow. Thanks for watching. Have a good day.